Our next session is titled Using MarkLogic and Semaphore to Implement RAG Search. And our speaker today is Patricia Kelley. Patricia is the Senior Enterprise Architect at AbbVie and has been working in the search, content services, and collaboration space for many years, designing and implementing solutions and building delivery teams at AbbVie, Walgreens, Allstate, Motorola, AT&T, and other companies. Trained as a writer, a linguist, and a teacher, she discovered that there was both art and science behind the information, behind how information is created, found, and used. She's passionate about wayfinding, making findability real on internet portals and company websites. She is also committed to recruiting and supporting new technologies from non-traditional backgrounds to find fulfillment supporting new technologists from non-traditional backgrounds to find fulfillment and success in her work. So Patricia, I will turn it over to you now. If you have any questions or requests, just let us know.
Thank you so much, James. And thank you, everybody, especially with your patience. I had hoped to be in person, but it just wasn't possible today. What we're going to talk about has a couple of facets. Yes, this is a prototype of new features that MarkLogic is currently embedding into their technology, but it's also a new effort for AbbVie as well. You might or might not know that we have roughly 260 architects that are embedded in at least 8 different business units. And so for most of the summer, I have been working on a committee that is centralizing their efforts, making our work more collaborative, making our work more consistent. And part of that required us to create a new web space for architects to put baseline materials, to put roadmaps, to put architecture positions, to understand what our inflection points were for which technologies we might choose and when we might use them. And that coincided with Imran and John coming to us saying, hey, we've got some new stuff, will you try it out? It was kind of a perfect match. And I'll tell you a little bit about AbbVie. Our mission is to discover and to deliver medicines that change people's lives. We really strive to create a remarkable impact on those lives in several areas: immunology, oncology, neuroscience, and eye care. And then also the aesthetics products that are part of our Allergan acquisition. And so if you're looking for more information about AbbVie, please do visit us at abbvie.com. So here's basically what we will do. We'll go over the premise and the scope of our efforts. We'll talk about the components that we use to create the solution, the process flow that the solution uses to produce responses and results, the process of ingesting data, of creating a semantic model, because that was at the heart of what we were doing, of the search itself, and then benefits and conclusions. And I do have a couple of slides later on. After this presentation is over, we'll share the deck, but we have some reference. So here's the premise. We're always looking to improve the findability of information on our intranet. And part of the work that my team does is actually figure out how to curate the content that goes in, how to create semantic models and taxonomies and ontologies so that we can tag things for findability. In this case, we collaborated with a progress team to test the new RAG augmentation on our existing MarkLogic and Semaphore platforms. We talked about the design and the work that was necessary to get the new RAG features in and installed, which, by the way, was pretty straightforward, so that was not an issue. We tested some new entity extraction functionality, some ontology features, and then we integrated the progress technology with emerging AbbVie GenAI components. And this is critical because we're also part of a GenAI team that not only works on generating answers and generating content, but also making AI available in other ways that isn't just all about documents. So what we learned through this process is going to help everything down the road. We did work with proprietary AbbVie content, the real stuff. We created a proof of concept that avoids uploading data to the internet hosts. Those two things are very important to us because while we could probably make this work on generic content or stuff that's external facing or stuff that wouldn't matter, typically the way we work internally on lab science data, on policies and processes, on manufacturing processes, those things are near and dear to our hearts, and we almost never send that information outside. So the kind of solution that we've created actually responds well to our normal governance and compliance procedures and requirements, which is critically important for us. It supports the content and the data in our on-premise MarkLogic and Semaphore environments. It uses our own emerging AI, and it delivers enhanced results. What this picture is sharing for you is a simplified architectural diagram. The way that the process runs through the components really did accelerate how quickly we were able to produce the situation. We looked at presentations, we looked at Word documents, spreadsheets, and other kinds of forms. And the first thing that we recognized is that a lot of these documents were emerging. That meant people were still working in Microsoft forms and not using PDFs. We also, in some cases, had XML snippets because we tend to deal with XML structures internally. So we took data as it was. We had some basic curation, and a couple of members of our team, Elise Hotchkiss and Alyssa Curry, are on, and those are, Elise is a search engineer, Alyssa is an ontologist, and they helped curate the data. They helped us create the data model. Out of this came a master index, an operational data store, and analytical views of the data. So coming in was raw data. Coming out was data that actually supports transactional apps, downstream feeds, some data services and APIs, and our enterprise data platform with access to our analytics tools like Click and Power BI. For your reference, we are compelled to create uniform security on these documents based on the topic of the documents. We use a governed data model. We did create some reference data, and we certainly created a lot of metadata that did not exist previously. So if you look at this model, this was a pretty clear picture of what went in, what process took place, and then how we make it available for later access. This particular slide talks about the GenAI pattern using the MarkLogic and Semaphore components. And so first, content would be ingested, as it is, into a multimodal database. This is important because often we have images, we have structured data, sometimes we have video files. It's kind of crazy, but it all gets curated and harmonized into the relevant model that is required both for the large language model and the other downstream apps. We do this to make sure that we can use data more than once. Semantically, we tagged the private content using classifications based on our own ontologies and by some ontologies and taxonomies that were developed as we created this process. We started out with a couple of different sets of information to see what would happen. The first data set that we started with were actually some policies and procedures that we use in our IT department, a little bit in our manufacturing teams. We kind of struggled with some of the PDF representation. And because the architecture program was coming up in a big hurry, we decided to flip over to the native Microsoft documents and to some images and some other data. But it all happened with a process that used fact extraction to create that entity management. So what are the big level categories that we could put content into? And then refined that with some human assistance to the data model that really optimized the ontologies and taxonomies so that the content could be turned into a knowledge graph, if you will. So using that semantic platform, the schema on the knowledge graph, the ontologies that were developed, queries were tagged against the graph to identify relevant content inside the data. We related those things to the subject, and actually we didn't do it, the process did it. And then the context of the queries was better understood and able to be submitted to our generative AI engine to create a response for the user queries. So a prompt was created using the augmented prompt generation approach. That included a hybrid search. It went against the knowledge graph. It increased the relevancy, and it improved the accuracy for our end users. And finally, the prompt was passed to the generative AI system. An answer was created and then revalidated against both the knowledge graph and the ontology, because those two things control our source of truth to prevent hallucination. And then the reference documents, the links to those documents were included in the answer to promote and validate the accuracy of the response. These were our components. On the top, we tend to build with React.js. We have our own kind of proprietary IDE for those developers at AbbVie who create user interfaces. Progress uses Kendo React. We looked at both. We eventually built our own. We know that they both work because we tested them both, right? We're using in the middle tier, which is a term we can talk about all day long. Spring Boot was included, Spring AI, and the MarkLogic Java Client API. For us, it took us a while to unpack the middle tier because we're developers, right? We don't necessarily trust what we don't understand. So we took that one step by step to prove out everything, and it is working. And in the service tier, then we use Azure's OpenAI. That's part of AbbVie's proprietary AI systems, and Semaphore 5.8. And then in the database tier, at the very bottom, MarkLogic version 11. Here's our process flow. We actually loaded documents, and the process extracted text and metadata. The process also chunks documents. Chunking is pretty important because when you go through the AI process, the chunks, which are sometimes at the paragraph level, but more often a sentence or two, an image, those are the elements that are compiled into the AI response. And each one of them has to be responsive to the query. Each one of them has to be tagged appropriately. And each one of those things has to respond as an object to the ontology model. So we used the knowledge model, the ontology, to analyze and classify all of these chunks. And we had people ask questions using natural language. We sent those questions to MarkLogic. MarkLogic used the Semaphore knowledge model to extract key concepts from the query. Now, the thing I will tell you is that extracting the concepts typically is a pre-processing thing. It doesn't happen between the time that a user asks a question and responses start to come back through the system. We try to push as much of this work to the data layer, which would have been Semaphore and MarkLogic, to be managed before queries are asked. And we continue to refine this process. When those things are in place, then we use the large language model to extract the key concepts from the query. The query is forwarded to the corpus. The corpus works with the extracted concepts and the chunks, and it returns the results with a relevance-based search. The customized prompts were generated using our own private data, and then they were delivered combined with the private concept and references to the full documents. So I'm going to back up a little bit and say that in ingesting, which was really an automated process, we loaded the content into MarkLogic's data hub. We transformed binary content into JSON representations. And then we mapped and classified the content using the data hub and the Semaphore API to produce a final version of the chunks. As we were developing the semantic model, then it again is an automated process to create the initial knowledge model or ontology. It's an automated process to use the content corpus and standard natural language practice to produce a set of concepts. It's a manual process, so humans in the loop, to extend the standard form model with a curated set of concepts. And then it's again an automated process to publish the knowledge model, which is the mapping of the concepts, to be used in classification and semantic integration. And you can see in the flowchart below basically how that works. We did not start from scratch. We used existing sources like our own glossary and controlled vocabularies. We do sometimes, if it's business-related data, start with commercially available taxonomies like WAND, and then we tend to have humans update the WAND taxonomies according to things that are different or weird or proprietary about AbbVie. And then that forms the basis of our chatbot knowledge graph that we used here in the POC. So there are a lot of streams of information going through here. Other WAND taxonomies that we've used in this kind of work in the past include things like service desk, data management, that kind of thing. That's when we use a commercially available thing. If it's about drugs or chemicals or biologics, we tend to use our own taxonomies. Again, I want to emphasize that we use knowledge graphs built from existing sources. We very, very rarely start from scratch. MarkLogic's implementation can use any one of these sources to inform a taxonomy or an ontology or a schema layer in the graph. These can be scraped. Entities can be extracted from here. Any one of these could participate in or be added to the knowledge graph. And then how the graph improves response. This is pretty straightforward. A person can ask a question about any social media platform that isn't specifically referenced anywhere. And the person can get the right response regarding AbbVie social media policies, citing the appropriate internal sources, because remember that one of the first feeds for what we did focused on AbbVie policy and procedures, and one of those happens to be social media. Semaphore knows that Pinterest is a social media platform, so if you ask the AI what the policy is for posting AbbVie information on Pinterest, it comes back with an answer. Not a document, not a PDF file that's impossible to get through, because in a kind of a sarcastic side note, our policy documents are written very strangely and our employees have a hard time figuring out what they mean and what to do. But if we run this through the large language model process, through the AI process, they actually get a real answer that they can use. And they have validation. They can go back to their work, or they can go back to their boss and say, here's where I found the answer. Here's where the answer is codified. I think we're good. Let's talk about search for a minute. It's an automated process to execute a query. into the system using a REST extension, and we tend to integrate using REST APIs first, second, and normally. It's also an automated process to analyze queries for key concepts using our Semaphore classification services. It's an automated process to produce a query that targets both the full text and the classified terms in a document, and it's an automated process to execute the semantic search against the MarkLogic universal index and produce a result set that's ordered by the score. When I first started at AbbVie, it was about 7 years ago, and somebody told me that I needed to find the policy document that talked about data classification because it's a cornerstone of how we do it. It literally took me 2 weeks to find that document. We can do it now in under 5 seconds. The POC had some specific goals and results. From the application tier, when we look at ingesting content and extracting text, we ingested around 1,000 policy documents and about 200 architecture documents. The policy documents were typically PDFs. The architecture documents were Word docs and PowerPoint files. When we were developing the Semaphore knowledge model, we developed n number of concepts with alternate labels for each. And forgive me, I don't have the final label, but I believe that we developed about 85 to 90 concepts. From a classification point of view, we ran the Semaphore process and embedded the generated metadata into the content corpus on MarkLogic. This is hugely important for us because it's the bedrock of how we return search results to any number of applications. And then when we ingested content and extracted the text, we did about, again, 1,000 policy documents and about 200 architecture documents. That looks pretty repetitive. I'll fix that later. In search, we use the content to create relevant-based search. And we typically use a REST API in our own UIs to manage this. When we talk about concept mapping, we used the concept mapping in the knowledge model to get key concepts from the queries and always deliver that through REST. And then we used MarkLogic demo GUI, so the Kendo GUI and the GenAI code to get responses from AbbVie's AI service as well. And they both worked extremely well. And finally, we changed the model to show positive results because any model can be tweaked. And as we read and curate the content, we get more precise about what it means over time. So we not only have automation for how to get more precise, we put humans in that loop too, just to make sure that we are being as semantically aware as possible. Security. Yep. Security is huge for us. As you can imagine, we create and ensure that we have secure environments for our content and delivering answers. All of our search applications offer role-based security by design, and MarkLogic and Semaphore both support that very strongly. In this POC, we demonstrated a few different security measures using user roles. All were successful in the implementation. If you are supposed to see something, you will. If you are not supposed to see something, you won't. So we have a little bit of API reference. This is here for your use later. These are the endpoints. We have specific purposes, and then the REST controller class. A few more, post and get. And that is what we've got for you today. I wonder if you have any questions.
Can you hear me okay?
Yes.
Excellent. Okay. So what we'll do is just holler out any questions you have, and then I'll repeat them on camera so that Patricia can hear it. All right, in the back. what? I'm gonna give you the microphone. We're going to do it this way.
This must be a good question.
When you were loading PDFs and Word documents and PowerPoints, a lot of that, I'm assuming, may have had images. Did you apply any vision as part of your AI process to better understand the contents of those images?
By vision, do you mean scanning to get meaning?
Yeah, to computer vision to analyze the images in order to know that it's a picture of a dog on a grassy field, for example.
And in some cases, we did. We did not do it with the Word and PowerPoint files. We have done it with our PDF files. It's interesting because not all of our end users or our authors understand that a PDF file is basically an image anyway. And we typically have to OCR to understand what the words are. We have done some significant work using computer vision against images, not for this project. We have teams of people who do nothing but analyze cells all day long. I mean, differences in cells, especially after the application of certain drugs. So yes, we understand what that means. We have done it. We have done it in an AI point of view, but not as part of this project.
Thank you.
Hi.
Did that answer your question?
Yeah, it did. It answered it. We got one more question for you right now, so hold on.
Sure.
Hi. For the RAG approach with the search, you mentioned that at the end of it, you're doing some analysis of the response to validate it against the model. Could you talk a little bit about that process?
Yeah, absolutely. And so Alyssa and Elise are part of a team that not only test things but build things, right? And it's normal for us to look at search logs, understand what the query was, what the response is, and not only to take the user response as, it was good or bad, it answered my question or it didn't into account, but we're looking at it with a critical eye about whether the response actually answered the question in the way we would have expected it to, right? We recommend that most teams do this on a monthly basis because it's the only way we're going to catch anomalies. Sometimes people in search especially throw up their hands and say, well, it's good enough, or I can't find what I want, so I'm going to call my friend and see if I can get a better answer. And neither one of those responses is good enough for us. So we typically run down the list of what was returned. Was it responsive? Did nothing get returned? And this is actually before AI generated responses, because there are a lot of search results or search return screens that, basically return nothing if it can't find what we're looking for. We tend to find that there are a couple big reasons for it. One, the content wasn't there in the first place. Two, perhaps it's a linguistic problem. Somebody calls it car, you call it automobile. And if there's no thesaurus in the background, the association's not going to get made. And we try to weed those things out. But it happens all the time. It's just a kind of a continuous loop thing that we do.
Perfect. Thank you. All right. One more question.
Hi. Could you give us indications on how long and how many people were involved in developing this proof of concept prototype?
Oh, gosh. Yeah. Actually, Imran, if I remember this correctly, we were about 6 weeks hot and heavy. It could have been 8. I think that there were 3.5 people or so on the MarkLogic side. And on our side, we had 1 UI developer. We had 2 search engineers and 1 ontologist. And one of our brand new engineers serving as a project manager.
Excellent. Okay. Any other questions? Who wants the mic? All right, here you go.
Hi. Maybe this was in there and I missed it. I didn't quite get how the LLM part and the Semaphore part are working together. It's a huge question for me, and I think other people, how to get curated, precise ontology data to augment the fuzzier LLM information.
Well, that's a really great question. For me, it's pretty linear, right? And this is why I talked about pre-processing. We use Semaphore as a preprocessor. So what we're looking for is entity extraction. Can it come up with category labels? We're looking for fact extraction. Is it semantically responsive to a question that comes in? And that information gets appended as metadata as well. Once that happens and the documents are chunked, again, a pre-process, then that goes through the LLM for generation into a response. So it's pretty one-directional. It doesn't go back and forth and back and forth and back and forth.
Good, thank you. Who's next? Oh, Imran has a comment. Okay.
Yeah. So in terms of the visual aspects of PowerPoint slides, they tend to be very, especially architecture documents, they tend to have a lot of diagrams. It turns out that even sort of the text indexing process does a really good job of grouping the words together in the original boxes where they were supposed to be. So that's kind of an automated way of visually getting information out of the PowerPoint diagrams.
That is absolutely right. And this is why I think the subject matter of the content that we used in the experiment was really, really important. Right? We weren't really looking for the boy with the red balloon and the dog on the grass, right? We're working with really definite concepts, definite words, definite labels, and definite concepts in the boxes.
Okay, last call for questions. Otherwise, I think we can wrap it up. So, Patricia, thank you so much for joining. I don't think you can see it, but you've got an entirely packed room here, and everybody was hanging on every word. So, very well done. Thank you, and thank you everybody for attending.
Thank you so much.